put on the board for you in case you want to take a picture or have one cheat sheet that's got all the information. I put like the specific points that we'll use to make the table. And then I also put like the little shortcuts if you are the type of person who likes to do it without the table. Make sense? Okay. Headphones should be on. Thank you. All right. So for cube root, let's go ahead and write down our table first, just so we kind of know where it comes from. So when you're taking the cube root of x, you're thinking what is multiplied by itself 3 times to get to that number. And since we probably don't want to have to graph a bunch of decimals, then we're going to choose numbers that you can take the cube root of. So -8 can be cube rooted, that's -2, because -2 multiplied by itself 3 times is -8. -1 can be cube rooted, that's just -1. 0 can be cube rooted, that's 0, and then 1, 1, 8, 2. So kind of like how you should have noticed that the quadratic points and the square root points are like similar, right? They're like the flipped version of each other. Same thing with cube and cubic root. Cubic and cube root is that they're the flipped version of each other. All right, so there's all the points. If you look, we've got 0, 0, 1, 1, and then 8, 2. -1, -1, -8, -2. So a cubic graph goes to the right 1, up 1, to the right 1, up 7. A cube root graph goes to the right 1, up 1, to the right 7, up 1. So similar patterns are just kind of the reverse of each other. All right. So if we look at this one, what are the transformations that you can see? Okay, so vertical stretch of 4. What else? Right 6. And up 2. Okay, so if I write down all those points, how do I vertically stretch by 4? Multiply the y. Multiply the y by 4, so that'd be -8, -8, -1, -4, 0, 0, 1, 4, 8, 8. How do I move right 6? For the x value, we add 6. So -2, 5, 6, 7, 14. That one's a little off the graph. Yeah. And then up 2? Add 2 to the y. Okay, and then these are the ones that we're going to graph. So -2, -6, 5, -2, 6, +2, 7, +6. Okay, before we graph it, somebody tell me, it's not the vertex, it's the locator point in this case, because we don't have a vertex technically, but can you guys tell me what it is so we know what the middle point is? It's the 6, 2. So this one right here is the middle. So when you are graphing a cube root from the middle, you do like kind of like half a parabola this way and half a parabola that way. This one is very shallow, and this one, ours is just going to be a lot more like curved, I guess. It's not going to be a shallow curve, it's going to be kind of like more obvious. So there's like the bottom half of the parabola kind of, and then here's another like half of a parabola. It should look like that. So if you're not sure when you graph the points, if you're kind of unsure about how to connect them to make them look right, you just look for that middle point, that locator point. And it's the same way you would find the vertex. Okay, so we already said the locator point is 6, 2. What's the domain of this graph? Negative infinity, positive infinity, that's pretty easy. What's the range for the graph? Negative infinity, positive infinity. So left forever, right forever, down forever, up forever. So these ones are kind of straightforward. When we put our stick figure, what's he doing? Yeah, he's like walking up out of a valley, and then he like climbs a boulder, and then he's like walking up over a hill. But he's walking up the whole time, right? Okay. So even though like the slant feels different as you go, it's just increasing the entire time. Okay. So we're going to say increasing is intense. Just write that. Increasing, intense. Yeah, right. Right, that's intense. What would I put for decreasing? None. Nothing there. What about max or min? None. Yep, there's no high point, there's no low point. It just goes up forever and down forever, so we can't put points there. Is the graph continuous? Can you trace it with your finger without picking your finger up? Yes. So it's continuous. So we haven't hit a graph yet that's not continuous. Yes.
So what is like a real life example of where we would see is
Cube root.
Yeah, it looks like it might be like used for.
Yeah, I think some of what we learn in math is like, yeah, I could see that graph would actually represent like a real world situation. And some of it is more about learning that these graphs show how certain numbers relate to one another, and that even if this specific graph doesn't deal with the real world, it could be mixed with other things and very advanced forms of math, where it's like in the middle of a problem and then you'd still want to know how it works. So you guys don't get the benefit of really seeing where math gets to work in the real world, because a lot of real world math is actually very advanced. So you guys learn like the pieces, you learn the vocabulary, you learn how to like describe the graphs, like that's what we're doing is we're learning like basic vocabulary. And then it's like the people in the really upper level classes that get to see it. And those don't really happen in high school. It's not until college that you really see the application of a lot of the stuff you guys learn, which is kind of unfortunate, but it is what it is. Yeah. All right. Now, if we do end behavior, we're going to say, let's look at the left arrow. So if I look at the left arrow, is it going up or is it going down? It's going down. So as x goes to negative infinity, y goes to negative infinity. So the left arrow is going down. As we look at the right arrow, what's the right arrow doing? Going up, so positive infinity. So left arrow is down, right arrow is up. Okay, and then the last thing we need our calculators for, what are we doing last? Intercepts. X-intercept, Y-intercept. And if you don't have a calculator, you're going to use this time to trade, your cell phone, get yourself a calculator.
How do you get set up your roots in your calculator? That's a pretty easy. Mine's special. Or like you don't have to buy.
Anyone know where the cube root button is?
I just do caret.
You can do caret 1/3. Mm-hmm. So I'll show you two ways to plug it in. So put the 4 first because we got that stretch. We can hit the math button and then number 4. That's one option. X minus 6 plus 2. Or if you want to do the option where you raise it to an exponent, the exponent is a 1/3. So caret 1/3. That's the other option. So a square root is a 1/2. A fifth root is a 1/5. A sixth root is a 1/6. So whichever way you want to plug it in, totally fine. It's the same regardless. The plus 2 is outside, yes. Now, your graph, if your calculator is like mine, some of you guys might have the color ones, and the color ones maybe don't do this, but it looks like there's a gap there. Is there a gap there? Yeah. There is not a gap. Your calculator has a very hard time with anything that looks like it's a vertical line. So right here, the slope gets very steep. Remember I said like it's climbing up a cliff? Anytime that happens, your calculator is going to be like, oop, I can't graph that because that's technically not a function and your calculator only graphs functions. This is where you have to be smarter than your calculator. And no, like I should not see any person turn in a graph on test day that looks like this. I will mark you down if I see a graph that looks like that because we plugged in the points. We know that that's there. And if you look at the table knows it's there too. It's just that your calculator screen has a hard time with it because your calculator doesn't do like vertical lines. And this is not actually vertical, but it's very close. And so your calculator is just struggling a little bit. Okay, so how do we want to find the x-intercept? We got a couple options, right? Which one do we want to use? Yeah, we can do y equals 0. Okay, so I'm going to get rid of this one, put y equals 0. And if I do that option, what do I have to do next? Okay, so second trace number 5. First curve, second curve. We don't even have to worry about that this time because there's only one answer. Okay, so when I did number 5, I just pressed enter, enter, enter. I didn't even have to move the cursor anywhere. So we've got 5.8750. Okay, how do I find the y-intercept? You said x is 0. How do you do that? Second trace number 1, x equals 0. Okay, so negative 5.268. And those are all the things. Yeah. Okay, so if we look at the growth on this one, so like I said, and if you look at the board, you can see it says over 1, up 1, over 1, up 7. So because we have a vertical stretch of 4, it's over 1, up 4, over 7, up 4. And if you count, you can see that. Over 1, up 4, wait, this is the middle. Over 1, up 4, over 1, down 4, over 7, down 4. So when you do the vertical stretch, it does not ever affect the part that it goes over. It only affects the part that goes up and down. So if you want to do those shortcuts instead, that's totally fine. You can call me over if you need me to help you with a problem just to make sure you've got it. That's totally okay. All right, we have an assignment, and you're going to be like, wow, this is deja vu. I feel like I've done this. Because it's going to be like, hey, tell me what the transformations are. Hey, graph it. Oh, some of them are dotted lines and solid lines and shading, and we are not going to kill a sugar glider. All right. Now, when it says write the name of the parent function, the parent function names are absolute value, quadratic, cubic, cube root. So you're writing the name of what it is. Does that make sense? So you're going to have to learn to recognize, oh, if it's got those vertical lines, that means it's an absolute value graph. If it's got a squared, it's a quadratic. If it has a third root, it's a cube root. All right, so we got to make sure we understand those names. And then you'll notice we've got some of the questions about like increasing, decreasing, domain, range, max, min, all that stuff. And then our new favorite, these ones where we compare to graphs. Aren't those our favorite? Don't we love those? So we can go over those together if we need to, if we get to the point where those are helpful. All right, let me hand these out.